Imagine this for a moment. A student sits in a silent room, books everywhere, pages full of formulas, definitions, dates, numbers. The student reads the same line again and again, trying desperately to remember it. But now, imagine something strange. What if the universe itself never memorizes anything? What if reality does not work through memory, but through understanding? I have always found this fascinating because when I looked at light, space, time, I never tried to memorize them. I tried to imagine them, and that changed everything. Imagine you are floating alone in empty space. No planets, no stars, no sound, only darkness. Now suddenly, beside you, a beam of light appears. And I ask you something impossible. What would happen if you could run beside that beam of light at exactly the same speed? Pause for a moment. Most people would search their memory for an answer. But memory is limited. Memory repeats what already exists. The universe does not reveal itself to repetition. It reveals itself to curiosity. So instead of memorizing equations, I imagined impossible situations. I placed myself inside the problem. I treated physics not as information, but as an experience. This is how many discoveries begin, not with knowledge, but with imagination guided by logic. Physics is filled with strange questions like this. What does time look like near light speed? Why does gravity bend space? Why does motion change the flow of time? None of these ideas were discovered by memorizing pages. They were discovered by mentally stepping inside reality itself. Now imagine another scenario. You are inside a perfectly sealed elevator, floating in deep space. No windows, no view outside. Suddenly, you feel your feet press against the floor. Are you standing on Earth, or is the elevator accelerating upward through space? At first, these situations seem identical, and a tiny realization changes everything. Because gravity and acceleration begin to behave like reflections of each other. This simple thought experiment eventually leads toward a deeper understanding of gravity itself. Not as a mysterious force pulling objects, but as the bending of space and time. Notice something important here. The discovery does not begin with memorization. It begins with visualization, with curiosity, with mentally walking through impossible worlds, because reality often hides behind ordinary thinking. Many people believe intelligence is the ability to store enormous amounts of information. But the universe does not care how many facts I can repeat. Physics only responds to understanding. A person may memorize every equation in a textbook and still never truly feel what those equations mean. But when I imagine myself moving near light speed, when I imagine clocks slowing down, distances shrinking, stars bending around gravity, the equations stop being symbols. They become reality. Take time dilation, for example. According to modern physics, time itself changes depending on motion and gravity. This is not science fiction. It has been experimentally confirmed many times. Atomic clocks moving at high speeds experience tiny differences in time compared to clocks standing still. Even satellites orbiting Earth must account for these effects. Without relativity, systems like GPS would slowly become inaccurate. This is what fascinates me. The universe behaves far stranger than human intuition, and memorization alone cannot easily understand strange things. Imagination can. Imagine holding a map of the Earth. You can memorize every road, every country, every ocean. But memorizing the map is not the same as exploring the world. Physics works the same way. Equations are maps. Thought experiments are journeys. When I imagined chasing light, I was not trying to sound philosophical. I was testing reality inside my mind. If light always moves at the same speed for every observer, then space and time themselves must change. That realization becomes the foundation of relativity, not because I memorized it, but because I followed curiosity to its logical conclusion. The human mind is extraordinary, not because it remembers perfectly, but because it can simulate realities that do not yet exist. Every major leap in physics begins this way. A question, a strange image, an impossible scenario. Then slowly, the hidden structure of reality reveals itself. Even now, modern physicists still rely on imagination. Black holes, quantum mechanics, warped space-time, the early universe. Many of these ideas begin as mathematical possibilities combined with thought experiments. Only later do experiments confirm them. Science is not blind guessing. It is disciplined imagination, curiosity controlled by evidence. And perhaps this is why the universe feels so mysterious. Because reality is not built like a library. It is built like an endless landscape waiting to be explored. No final page, no final answer, only deeper question. So when I looked at the stars, I never saw objects to memorize. I saw mystery. I saw moving clocks, curved geometry, invisible force, hidden dimensions of reality. I saw a universe stranger than human habit, and I realized something profound. Understanding begins the moment memorization ends, and imagination begins asking better questions. Tonight, when you look into the night sky, remember this strange possibility. The greatest discoveries may not come from repeating what is already known, but from daring to imagine what reality truly looks like beyond human intuition. Because the universe does not reveal itself to memory alone, it reveals itself to curiosity. Reality is far stranger than memory can contain.